Welcome back. Waving Hand in this episode will dive deeper into how databases are structured and organized, the DBMS architecture, what a schema and an instance are, what metadata means, and the many types of keys that keep your data consistent. By the end, you'll be able to read DB diagrams and explain why keys exist in real systems. First, DBMS architecture. At a high level, a DBMS splits responsibilities so systems are scalable, secure, and maintainable. The two common ways to think about it are the three schema logical levels, external/conceptual/internal, and the three-tier deployment, presentation, application, data. External view, level what users or apps see. Each user group can have a different view, e.g., HR sees payroll fields. Sales sees customer contacts. Conceptual, logical level. The global schema, tables, relationships, constraints. This is the unified design the DBAs and architects agree on. Internal, physical level. How data is actually stored on disk, file layouts, indexes, blocks. Real-time example, banking app. External. Customer mobile app shows balances only. Conceptual. The bank's DB schema has accounts, customers, transactions, branches. Internal. Data stored in pages, transaction logs, and B-tree indexes for fast lookup. Next, schema. A schema is the blueprint or design of the database. Instance. An instance is the data at a particular moment in time. The schema is relatively stable. Instances change all the time. Example, schema. In an e-commerce DB, you define tables products, orders, order items. Instance. Today there are 12,452 products and 3,291 orders. That exact set of rows is the instance. Metadata, literally data about data. Metadata describes the structure, types, ownership, and lineage of your data. It's what helps systems and humans find and understand the real data. Types, quick bullets on screen with icons. Structural metadata, columns, types, keys, indexes. Descriptive metadata, descriptions, tags, labels. Administrative metadata, who owns the data, retention policy, access control. Real-time example, when a data analyst opens information_schema.columns in MySQL or PG_catalog in PostgreSQL, they're reading metadata, column names, types, defaults, whether null is allowed. 5. What is a key and types of keys? Keys are special attributes, columns, used to identify rows uniquely and to link tables. They enforce integrity and enable fast lookups. We'll step through the main key types with concrete examples. Types of keys. 1. Superkey. A superkey is any set of columns that uniquely identifies a row. It might have extra columns you don't need. Example. In the users table, user ID, email, phone number can uniquely identify a user. 2. Candidate key. A candidate key is a minimal superkey, no extra columns. There can be multiple candidate keys. Example. In the users table, user ID and email could both be candidate keys if both are unique and minimal. 3. Primary key. Primary key is the chosen candidate key for the table, the main unique identifier, usually enforced not null and unique. Example. The user ID column is chosen as the primary key to uniquely identify each user. 4. Alternate or secondary key. An alternate key is a candidate key not chosen as primary. For example, email could be an alternate key if ID is primary. Example, email can be an alternate key. It's also unique but not chosen as the primary key. 5. Foreign key. A foreign key is a column in one table that references the primary key in another. It creates relationships and enforces referential integrity. Example. In the orders table, user ID is a foreign key referencing users, user ID, establishing a relationship between orders and users. 6. Composite key. A composite key uses multiple columns together as the unique identifier. Example. In an order items table, the combination of order ID and product ID can serve as a composite key to uniquely identify each item in an order. 7. Surrogate key. A surrogate key is an artificial key added only to uniquely identify rows, e.g., auto-increment ID, often used when natural keys are composite or unstable. Example: an auto-increment order item ID in the order items table, used solely for identifying each record, regardless of the natural keys. 8. Unique key. A unique key enforces uniqueness but may allow null depending on DBMS. Primary key does not allow nulls. Example: you set a unique constraint on email in the user's table. When trying to insert a duplicate email, the database blocks the insertion, enforcing the uniqueness. Quick recap: DBMS architecture separates views, logical design, and physical storage. Schema is the blueprint. Instance is a snapshot. Metadata is data about data, keys, primary, foreign, composite, surrogate, etc. Keep your data correct and link tables. In the next video, we'll build a small schema and write SQL queries to show how these keys work in practice.